Okay guys, our lesson today is to be able to divide powers with the same base. And very simply, we're going to use a rule to do that. And the rule says simply this. It says to divide powers, with the same base, we will subtract their exponents. And we can take a look at some patterns to kind of uncover where this rule comes from. All right, so let's take a look at that and see some patterns that might be able to help us. So let's take a look at the quotient. 2 to the 4th power divided by 2 to the 2nd power. If we write out 2 to the 4th power as a product of its factors, that'd be 2 times 2 times 2 times 2 in the numerator. In the denominator, 2 to the 2nd power is 2 times 2. If we cancel out 2's in the numerator and 2's in the denominator, because 2 divided by 2 is 1 and 2 divided by 2 is 1, we're left with 2 to the 2nd power. And we can see that this 2 to the 2nd power is the result of subtracting the exponent of 4 and the exponent of 2. 4 take away 2 gives us the power. Notice the base stays the same, right? The base is still 2, but we subtract the exponents and we get the resulting answer. So, if we take a look at something like this down here, 7 to the 7th power would be 7 times 7 times 7 times 7 times 7 times 7 times 7 in the numerator, and in the denominator we'd have 7 times 7 times 7, right? And we would see the same result. If we divide out 7's in the numerator and 7's in the denominator, because they're going to be 1's, we're left with 4 powers of 7, right? 7 to the 4th power. And once again, we can see 7 to the 4th power is the result of the base staying the same and simply subtracting the exponents of 7 and 3 to get the exponent of 4. So that's where the rule comes from, boys and girls, and we just want to be able to use that rule and apply it to some problems, right? So let's take a look at some. So we have an example of 2 to the 6th power divided by 2 to the 4th power. When we divide powers with the same base, the base stays the same. We simply subtract the exponents. 6 minus 4 gives us 2 to the 2nd power. The second example, we have negative 7 to the 9th divided by negative 7 to the 3rd power. The base is going to stay the same. We subtract the exponents, 9 minus 3. That's going to give us negative 7 to the power of 6. Our next example, h to the 7th divided by h to the 6th. Right? The base is going to stay the same. We subtract the exponents, and that would give us h to the 1st power, or just h. Right? And if you take a look at these examples down here, you would all do these problems the same exact way. When we're dividing powers with the same base, we simply subtract the exponents. So 9 to the 7th power divided by 9 to the 4th power, the base is going to stay the same. We subtract the exponent, 7 minus 4. It's going to give us 9 to the 3rd power. 4.2 to the 6th divided by 4.2 to the 5th. The base is going to stay the same. We subtract the exponents. We get 4.2, or 4.2 to the 1st power. Negative 8 to the 8th divided by negative 8 to the 4th. Base stays the same. We subtract the exponents. 8 minus 4 is 4. We get negative 8 to the power of 4. And finally, we have x to the 8th divided by x to the 3rd. Base stays the same. X, we subtract the exponents. 8 minus 3 is going to be 5. And we get x to the power of 5. Now, we want to also be able to simplify expressions here, so we have to kind of combine some rules here. So if we look at this example, 3 to the 4th times 3 to the 2nd divided by 3 to the 3rd, first we want to take care of that numerator where we're multiplying powers with the same base. We want to add those exponents in the numerator, so that's going to be 3 to the 6th power. We still have the 3 to the 3rd power in the denominator. So we take care of the numerator first, gives us 3 to the 6th power, and now we are dividing powers with the same base. Base stays the same, subtract the exponents, we'd get 3 to the 3rd power for that answer. Another example using variables, right? We could do this problem a couple different ways, but let's do it this way first. All right? I'm going to subtract 8 to the 10th and 8 to the 6th. That's going to give me 8 to the 4th power times 8 to the 7th divided by 8 to the 4th. That's going to give me 8 to the 3rd power. Now we're multiplying powers with the same base. We're going to add those exponents, and that's going to give me 8 to the 7th power. Or we could have done the problem this way, right? I'll do it in a different color. Let me split my screen here. Right, could have done it this way. Do it in blue. We could have multiplied across first. 8 to the 10th times 8 to the 7th. We're multiplying powers with the same base. I'm going to add their exponents. That's going to give us 8 to the 17th. In the denominator, 8 to the 6th times 8 to the 4th. That's going to give us a to the 10th because we're multiplying powers with the same base. We're going to add those exponents. And now we divide powers with the same base, so we're going to subtract those exponents, and we would get 8 to the 7th that way. So you can do the problem either way. That being said, let's take a look at some examples down here, right, where you guys can kind of work on your own. All right, let's take a look at, let's do this first one here. Let's take care of that denominator first, so that's going to be 2 to the 15th over 2 to the, what's that, 3 plus 5 is 8, 2 to the 8th, and then we're going to subtract those exponents. 15 take away 8, that's going to give us 2 to the 7th power. This next one, let's do d to the 5th, d to the 9th, that's going to be d to the 14th power in the numerator, and in the denominator, that's going to be d to the 9th power. Now we're multiplying powers with the same base. We can subtract those exponents. So 14 take away 9, that's going to be d to the 5th power. Then this last example, 5 to the 9th divided by 5 to the 4th, that's going to be 5 to the 5th power. I'm going to subtract those exponents here. And then 5 to the 5th divided by 5 to the 2nd, that's going to be 5 to the 3rd power. And now we're multiplying powers with the same base. We're going to add those exponents. That's going to give us 5 to the power of 8. All right. We have some more examples down here. All right, we've done problems like D and E, so they're pretty easy, but let's look at F. F's a little bit more interesting. We have, I'll recopy it down here, letter F. We have 12 times W to the 5th. We're dividing that by 2 times W. Well, the coefficients, we're going to take care of them first. 12 divided by 2, it's going to give us 6. And now we take care of the variables. W to the 5th power divided by W to the 1st power, right? That's really to the 1st power. Subtract those exponents. It's going to be W to the 4th power. So the result would be 6 times W to the 4th power for letter F. All right. Let's look at something like letter G, right? A little bit more interesting because we have different bases. So let's do letter G down here. Let's do 3 to the 4th divided by 3 to the 2nd. We're dividing powers with the same base, so we subtract their exponents. It's going to be 3 to the 2nd power times 5 to the 2nd divided by 5 to the 1st. It's going to be 5 to the 1st power. And then 7 to the 5th power divided by 7 to the 3rd power. It's going to be 7 to the 2nd power. Now, we really can simplify that whole mess there. Right, 3 to the 2nd power we know is 9. 5 to the 1st power we know is 5. 7 to the 2nd power, 7 times 7, right, that's 49. So 9 times 5 times 49, right, we could use a calculator for that. So we have 9 times 5 is 45. 45 times 49, that's going to be 2,205 for letter G. All right, let's try letter H. Do that up here. 5 to the 6th divided by 5 to the 4th. It's 5 to the 2nd power. 7 to the 4th divided by 7 to the 2nd. That's 7 to the 2nd. And then 8 to the 3rd divided by 8 to the 2nd. That's going to be 8, or 8 to the 1st power. Either way you can write it. We'll leave it as 8 this time. 5 squared, we know that's 25. 7 squared, we know is 49. Times 8. And we could use a calculator for that. 25 times 49 times 8 is going to be equal to 9,800 for letter H. And let's do letter I as well. Why not? We'll do letter I down here. Negative 2 to the 5th power divided by negative 2 to the 2nd power. That's going to be negative 2 to the power of 3 times 3 to the 4th divided by 3 to the 1st. That's going to be 3 to the 3rd power times 5 to the 7th divided by 5 to the 4th. It's going to be 5 to the 3rd power. Negative 2 to the 3rd, that's going to be negative 2 times negative 2 times negative 2. It's going to be negative 8 times 3 to the 3rd power. That's 3 times 3 is 9 times 3 is 27. And 5 to the 3rd power is 5 times 5 is 25 times 5 is 125. All right, we could use a calculator for that multiplication. So we're going to do negative 8 times 27 times 125. That's going to be negative 27,000. All right. And you have a bunch of problems on this page here. You guys can kind of try those on your own, but let's play around and pick some of the better ones to do. Let's do problem 4. 24 divided by 6. We know that's going to be 4. And then k to the 9th divided by k to the 6th. It's going to be k to the 3rd power. So we get 4 times k to the 3rd power. Let's see. Anything else look interesting? You guys can play around with some of these. We did some examples like that. Let's look at, I don't know. I guess we'll do all of them. What the heck? Right? So this is going to be 2 to the 2nd divided by 2 to the 1st. That's going to be 2 to the 1st times 3 to the 3rd divided by 3 to the 1st. That's going to be 3 to the 2nd times 4 to the 5th divided by 4 to the 4th. That's going to be 4. So this is 2 times 3 to the 2nd power is 9 times 4. That's going to be 2 times 9 is 18. 18 times 4, that should be 72 for problem 5. All right, problem 6. We have, let's see, negative 3 to the 4th divided by negative 3 to the 2nd. That's going to be negative 3 to the 2nd times negative 4 to the what? 3 minus 1 is going to be 2 times, it's going to be 5 to the 2 minus 1 is 1. Negative 3 to the 2nd power, that's 9 times negative 4 to the 2nd power, that's going to be 16 times 5. So we have 9 times 16 times 5. That's going to be equal to 720. Alrighty. Example 5. Oops. Example 5. 16 divided by 8. That's going to be 2. T to the 4th divided by t to the 1st. It's going to be t to the 3rd power. X to the 6th divided by x to the 4th. That's x squared. Y to the 14th divided by y to the 9th. It's going to be y to the 5th power. Right? We have to leave our answer that way because we cannot combine powers where they have different bases if they're variables. If they're numbers, yes, we can. But if they're variables, we cannot. 3 to the 4th divided by 3 to the 1st. That's 3 to the 3rd times x to the 4th divided by x to the 2nd. It's going to be x squared. 3 to the 3rd power, we can evaluate that. 3 times 3 is 9, times 3 is 27. So we should have 27 x squared for that problem. All right, and we'll finish it up with these problems down here. All right, you guys can try these on your own and see if you get them right, but I'll do them as well. That's going to be 4 to the first power times 5 to the first power times, that's going to be 6 to the first power as well. 4 times 5 is 20. 20 times 6 should be 120 for problem 8. Problem 9, that's going to be 6 to the first power for these, or actually let's do it the other way because we all have the same base, right? So let's do it this way. Multiplying powers with the same base, we're going to add their exponents. So that's going to be 3 plus 6 is 9. 9 plus 4, that's going to be 6 to the 13th power in the numerator. In the denominator, we have 2 plus 3 is 5. 5 plus 3 is 8. That's going to be 6 to the 8th power. Dividing powers with the same base, we subtract their exponents. 13 take away 8, that's going to be 5. If we want to evaluate 6 to the 5th power, right, we could use a calculator for that. That's going to be 6. Let's see. Y to the x, it's going to be 5. That's going to be 7,776 for 6 to the 5th power. And then our last one, we have different bases, so we'll do each of them one at a time. 2 to the 5th divided by 2 to the 3rd, or negative 2, that's going to be negative 2 to the 2nd power, times negative 3 to what power? 4 take away 1. It's going to be 3. And then negative 5 is our base. And 3 minus 2 is going to be 1. And negative 2 to the 2nd power, that's going to be 4 because that's negative 2 times negative 2. Negative 3 to the 3rd power, 3 times 3 is 9, times 3 is 27. But we have an odd number of negative factors, so that's going to be negative 27 times negative 5. Negative times negative is positive, right? So our answer, our product's going to be positive. 5 times 4 is 20. 27 times 2 is 54, so that should be 540 for problem number 10. All right, so that's all the problems that we have for the lesson. I hope that that's been helpful, and we will see you soon.